Okay, 1.5 alcohols and ethers. We want to see what is the alcohol. Anything, any carbohydrate that attached into OH, like here is hydrocarbon, right? Attached to the OH, it is alcohol. Now we want to see how we do name the alcohol. Again, we need to look at like this one. This carbohydrate attached to the OH is alcohol. So the main chain has like 3 carbons, so it's going to be propyl, right? Because it's alcohol, OL will attach at the end. Propanol and OL will be attached at the end. On the first carbon, the OH is attached. We'll have to put the position of the OL. Okay, now here, 1, 2, 3, again, propanol. On the second carbon, the OH is attached. We call this one the primary carbon. Why? The primary alcohol. Because this carbon is just attached, the carbon that attached to the OH is attached to the 1 carbon. We call this one secondary carbon, secondary alcohol, because this carbon that OH attached to that is attached to 2. That's why this is secondary. Okay? Any question?
No.
And we have a tertiary as well. Tertiary means it is attached to the 3 carbon. The carbon that attached, so here, the carbon that attached to the OH, this carbon attached to 3 carbon. That's why it's 3rd degree alcohol or tertiary. We did talk about the second degree alcohol, the 1st degree alcohol. I'm gonna clear that. Poly alcohols means you have more than 1 OH attached. How do you name that? On the first carbon and second carbon, you have OH. So the position of that is 1, 2. Ethane, because you have 2 carbon in the main chain. Diol, because you have 2 of alcohol, right? 2 OH. Need to say diol. Here the main chain is propanol, because 3 of them, you see that you have to say propane triol. And the position of that is 1, 2, 3, 1, 2, 3. Any question?
No.
A cyclic alcohol, again, you have a cycle and the alcohol is attached to that. If you have a benzene ring attached to the OH, the name of that is phenol. Make sure you memorize that. These 2 are not important, but ignore them. Just that one was important. Now we want to name this the main chain. Of course, this is your main chain, right? And it is alcohol. See, this is 1, 2, 3, 4, 5. You have a 5 carbon in the main chain, so it's going to be pentanol. On the second carbon is OH attached, is 2 pentanol. And on the second carbon, there is a branch, 2 methyl, 2 pentanol. Let's look at the answer. Where's the answer? Here, 2 methyl, 2 pentanol. Okay, next one. Draw the structure of butanediol. So but means 4 carbon in the main chain. On the first carbon, third carbon, you have OH. In the first carbon, 1, 2, 3, you have OH, and you put the OH around that. Any question? It's good?
Yeah, it's good.
Draw the structure of this 3-ethyl 2-pentanol. So 3-ethyl is branch, of course, it's alcohol, and the second carbon you have OH attached, and pent means 5 carbon in a main chain. You have ethyl on the third carbon, and the second carbon you have OH attached, and that's it. Name the following. See the main chain, 1, 2, 3, 4, 4 carbon in the main chain. So butanol. On the second carbon you have OH, so we're going to 2 butanol. On a second carbon and a third carbon, there is a branch, 2,3 dimethyl. So this is the page 41, question 1, 2, 3. Now, properties of alcohol, OH attached to that. Of course, this is going to be a going to be polar molecule. As the size of molecule is going bigger, the boiling point begins because the surface content increasing, and it's harder for us to pull them apart, right? So that's why bigger is the molecule. Of course, you have a higher boiling point. So question number 5, you do, this is page 42. A reaction involving alcohols. See, if you have ethane and alcohol, what's gonna happen? So ethane has a double bond. So of course, this double bond will break. And water is H2O, right? It has a hydrogen and OH, plus and minus. So it need to make a bond. So I need to have H on one of them and OH on the other one. Markovitch rule, the rich getting richer. This has a 2 hydrogen. That's why the hydrogen come here and OH come here. And we have this 2-butanol. So you know that the CO plus 2H2, the H will attach to that. It's going to be CH3OH. It's going to be composition and this decomposition of that one. I'm not very strictly about these two, just knowing this type of reaction is important for me. Combustion of alcohol. So you know that any hydrocarbon burn in the oxygen, it will give you both of water and carbon dioxide if the reaction is complete combustion. Okay, so alcohols to alkene elimination. Okay, so when you have alcohol, you know, is a reverse reaction of this one that we did talk about. This reaction now happened, a reverse of that. Reverse of that, this H and OH come out and you have double bound and you'll get this, right? So this is the reaction. You have alcohol, the OH and H get out and you have a double bond between these two. Now, of course, these two together will give you water. Any question?
No.
Now, draw a structural diagram to represent the additional reaction. Again, this has a double bond. This double bond H2 is H and OH ion, right? So what happened? This bond will break. Now you need to have H and OH. A rich getting richer. It has 2 hydrogen, it has 1 hydrogen. So the hydrogen go to the one that has bigger number of the hydrogen. And OH is here. And you can name it, it's going to be methanol. Now write the balance equation and name reaction and product for dehydration reaction of the ethanol. So you have ethanol dehydration means OH getting out and it form water. So OH and H from that getting out, you have a double bond. So this is the reaction. And the complete combustion. Complete combustion means reaction with oxygen. If you CO2 and H2 and you need to balance it. Here, draw structure IUPAC name for 2-methyl-2-butanol. 2-methyl-butanol means 4 carbon. On a second carbon, you have a OH because it's 2-butanol. And on second carbon, you have a big branch of the methyl. That. So, and how do we get that? So, of course, you need to know that OH here and H, one of the H's here will get out and become H2O, and this will become double bond as you see here. So you have to write it from here to here. How do we get that? Now this is page 44. You do question number 7. Number 8. Now here is ethers. So ether, whenever you have this oxygen in the middle attaching to the carbon, I'm going to give you an example. Ether. So see this hydrocarbon, and oxygen attached in the middle of them. This will be ether. These are different types. So it's not, OH attached to a carbohydrate. As if you compare them, of course, OH is what kind of bond it is? Is a polar, like the whole molecule is polar molecule. That's why it has a bigger, highest boiling point compared to ether and compared to ethane. Ether is a slightly polar. That's why I see the boiling point is higher than alkanes. Alkanes has a lower boiling point because it is non-polar molecule. And of course, H2O is biggest boiling point, highest boiling point. Naming ethers, I just want to go through this. Okay. See, this is 2 groups of hydrocarbon is attached to oxygen. I know this is ethers. How do I name that? The biggest chain gonna be your main chain. Just put in your head. This is the biggest chain, has a 3 carbon compared to that one. This is the main chain. That's why it's gonna be propane. And the one that is attached to the oxygen as a branch, the oxy will be attached into that. I will say that because it's 2 is gonna be ethyl, right? It's gonna be ethoxy. It's oxypropane. Any question? Now, for the naming, this is page 46. You do question number 11. Preparing ethers from alcohols. So 2 alcohol react with each other will give you ethers. How? See, this one is a methanol, and here's another methanol. One of them H will get out, and from the other one OH get out. And CH3, see, CH3O. And here is CH3. And H and OH form water. We call this one condensation reaction. 2 alcohol react with each other, give you the ether, going to be condensation reaction. That is, write a balanced equation, draw the formation of the 1-propanol. So 1-propanol, we show formation of an ether from 1-propanol. Okay, you have 1-propanol and another 1-propanol. Of course, the H from that and OH from that get out, form H2O, and I'm just going to attach these 2. As you see, you have that here. It's going to be propoxypropane. So this is the page 48. Page 48, question number 4, 6, 7. 4, 6, 7.